Hello viewers, welcome to my channel CADX Machines. In this video, I will be showing you the design process of conveyor system design. As you can see in my SolidWorks window, I have already opened my design conveyor system that I have designed over past few days. So in this video, I will be presenting the detailed design process that I have followed during the design of this conveyor system. I have divided this process into 5 steps, which are namely: first process name is problem definition, second step name is component selection, third step is 2D layout planning, and fourth step is frame design, and last step is assembly of that conveyor system. Let's begin with the first step, which is problem definition. For that, I have prepared an Excel sheet that I will be showing you, in which problem definition has been given. Here, coming to the Excel sheet, the material to be moved is the corrugated boxes of size 250 by 250 and 250 mm, and weight of each box is 3 kgs, and required throughput is how much quantity of boxes are required per minute at the output of the conveyor, which is given 5 boxes per minute. And from here we can also calculate the linear speed of the belt. That is, it is given by the formula boxes per minute multiplied by pitch. That formula, boxes per minute required is 5 and pitch is 0.5. Pitch is calculated by the equal size gap of a box between the 2 consecutive boxes. That will give me the 0.5 of meter of pitch, and if we multiplied it by 5, it will be giving me 2.5 meters per minute. That is, by unit conversion, it will come out to be 0.42 meters per second. And other requirement is geometry requirement. The boxes that need to be transferred are through a distance of 4000 millimeter, that is 4 meter, from first point to the second point, and at a height of 900 mm. So this concludes the requirement step of conveyor system design. Okay, coming to the next step, which is component selection. And in that selection, I have firstly selected the belt selection. The standard selected is as per IS 1891. It is the common standard that is being used in the industry. And material, I have selected the PVC. As PVC I have selected because it is common practice to choose PVC if your operating environment is neat and clean. And in this application, our environment is neat and clean. That's why I have selected the PVC. And nomenclature would be PVC 160 by 2. Here PVC is the material and 160 is the tensile in the belt, and 2 is the number of plies, and safety factor is 8, and width of that belt is 300 millimeters, and top cover thickness will be 1 mm, and carcass thickness will be 2 mm, bottom thickness will be 1.5 mm. So by adding these 3 thicknesses, we will get the final thickness, which will be 4.5 millimeters of PVC belt. Okay, next component is roller selection. That will be the main roller of the belt that will be running the belt, and it is pulley diameter is first parameter that is being calculated, and it is calculated by the common practice formula, which is 30 to 50 times T, which is the total thickness, and 30 to 50 is the common factor. And if we use lower limit 30 and multiplied it by 4.5, the total thickness, we will get the 1.135 millimeters, and in standard size of approximation rounding off, we will get 150 millimeters of roller dia. Okay, next is the support roller, and support roller I have eliminated, so I am not considering them, and instead of support rollers I have used support sheets that I will be showing you in the CAD. Now this is the pulley diameter is 150 mm, and pitch will be, this is not of much interest. Next parameter is belt tension calculation, and here number of boxes held is equal to the total length divided by distance per box, and which is total length is 4 meters, and distance between per box is 0.5 meters, which is giving me 8. So number of boxes held at any time will be the 8, means 8 boxes will be any time on the conveyor when it is running. And now calculate the total load. Load of one box is 3 kg as mentioned earlier, multiplied by 8 will give me the 24 kgs of weight. And now calculate the belt mass, belt weight, which is mass per unit area of the belt into total area. That is, if we go by the PVC catalog of the suppliers, then we will get a typical range of area weight per unit area, which is around 5 kg per meter square, and multiply it by the total area, which it is 8 times 0.3. So the total load of the belt will be 12 kg, and effective pull will be this load plus this load multiplied by G multiplied by coefficient of friction, which is giving me 7.658, and coefficient of friction selected is 0.005, and power will be calculated by the formula pull multiplied by velocity divided by 1000 into efficiency, which is in kilowatts. This is in kilowatts, so 0.0000098 kilowatts. Now coming to the motor selection. For that, drive pulley diameter is 150 mm, velocity is 0.042 meters per second, and RPM from there will be calculated V times 60 divided by 3.14 into D, which is coming out to be 5.35. Now torque on the motor will be Fu is equal to 17.66, which is the full load, and R of that roller is 0.075 meters. Then torque will be 1.3245. Continuous torque will be divided by efficiency. This torque divided by efficiency will give me the 1.766 Newton meters. And one more factor that we will have to add is the startup torque factor, which is 2, is a typical value of 2. So if we multiply 1.766 by 2, it will give me the 3.532 Newton meter of torque. This is the design torque. Okay, next parameter is the gear ratio. This is the process of motor selection. So first I have calculated the design torque. Now I am calculating the gear ratio. Gear ratio will be calculated RPM of 4-pole AC motor. This is common formula is 1440 rpm, and I is the gear ratio. It will be motor rpm divided by required output speed. Motor rpm is 1440, required rpm is 10, so 1440 divided by 10 will be 144. So selected gear ratio will be 150 by 1. So now final motor spec: power as per the catalog will be the 90 watts availability, and torque availability on that wattage is 83 Newton meter, and rpm availability is 10 rpm. So the motor is selected. This is the motor part number, and this is selected from the Oriental Motor website. So I have downloaded the CAD from there. Now final step is the bearing selection. I am calculating first the minimum shaft dia that is required for the bearing shaft. So for that I have taken the torque is 113 Nm, force factor of safety is 1.5, tau is 300, which is the maximum allowable shear stress for the SS material, and if we put in the formula 16T upon pi d cube, then we will get the diameter value to be 14.414, which is after approximation will come out to be 15 mm, and the radial load is 85 Newton, factor of safety is 1.5, and now static load is 127.5 newtons, and operating temperature range will be in-house, means it will be operated around 20 to 26 degrees of temperature, and the bearing which is selected from the SKF website is FY503MH. This is my bearing. So this concludes the component selection phase. Now moving to the next step, which is 2D layout. It is the third step of the process of conveyor design. As you can see in my tree, I have designed this 2D layout in the initial stage of the design process. So let me explain how I did it. So this is basically a 2D plan of what we will be doing. Here is the major dimensions I have given in the sketch. Here you can see the dotted center line circles. These big circles are two rollers, this one and this one on the each end, and this is small circle as support rollers. So these are not in the current design. I have removed and placed a band sheet instead of support rollers, and here is the height dimension of the conveyor system, which is 895.5. This is height, and 4.5 mm of belt thickness will be coming on top of this, and if we add them, then the total height will become 900 millimeters. That is our main parameter. So that way I have proceeded with the frame design, which will be the next step of this process. And this is the 200 millimeter. At 200 mm I have placed this long member for support in the design that I will explain in the next step. So this is the frame design step of the conveyor design process. Here I have initially made the 3D sketch of the components of the frame that I will be placing at. So I have placed two long members of 3800 length, this and this, and below them on the left hand side I have placed these two members of height 820.5. for the high dimension, and between these long members I have kept the distance of 440 millimeters, and as in the machine layout I have mentioned this dimension to be 200, so I placed a cross member at 200 height, and again a long member for support. This member at of dimension 3580, and in the next step I will mirror the members over here on left hand side, that will be coming on the also on the right hand side. So next, proceeding to the actual weldment shape. So here I have chosen the 440 by 40 by 4 mm as my structural member profile. It is a square tube of outer size of 40 by 40 and this thickness of 4 mm, and I have placed the members on my 3D sketch. This second, third, fourth, fifth, sixth and seven members I have placed, and in the next step I have mirrored these 1 2 3 4 members on the right hand side. This concludes the frame design step. Now starting with the final step of the process, which is assembly of the conveyor system. As you can see in my window, I have exploded the components of the conveyor. Over here I have started in the first, I have inserted the frame and placed it in the coordinate system, and second I placed the motor, which is over here as you can see, and motor mountings I have placed, bearings, this is the bearing, this is placed here, and next is the conveyor belt, which is this placed here, and these three are the supports of the conveyor which will be coming in the bottom, and these two are the rollers, first and second, and here is the tensioner mechanism. As you can see, when we will tighten this bolt, this upper plate will be sliding in this direction, positive X direction, and same here also, the upper plate will be sliding here, and now the motor mounting plates are here. Let me explain you how I mounted this motor. The motor will be mounted using two plates. One is the fixed plate, which will be fixed to the chassis or in a way welded to the chassis, and this plate is assembly type. Let me just hide this plate so that it's more clear. This plate will be fixed on the motor flange with the help of 1, 2 and 4 bolts, and once this fixes the motor, and the complete assembly will be mounted on this motor mounting plate using this 1, 2 and 3, 4 bolts. So this completes the motor mounting and also the assembly of the conveyor system. So viewers, hope you like my detailed video. Please subscribe to my channel for more such videos. I will keep posting such videos, and if you have any suggestions or questions, then please let me know in the comment below. See you in the next video. Thanks for watching.